Welcome everyone. Welcome to this new chapter, chapter 7, Summation of Series and Method of Differences. In this chapter, we're going to cover three things. One, I'm first going to define what is a sigma notation. Then after that, I'm going to introduce this method called Method of Differences. And some application of this, if you are given a certain formula, how to find the value of sums. Never mind if you don't know what I'm talking about, later on we come back to this, and I'm very sure it will be quite clear after that. I want to refer all of us to 7.0 and 7.1 of your notes. Let us first start with a definition of this sigma notation. Now, this sigma essentially just means summation. So later on, I'm going to give examples to illustrate how we use this sigma notation. But essentially, it is about something plus something plus something plus something. If you write something in this sigma notation, it is to represent something plus something plus something. I give you a simple example. Suppose I write it like that. Now, this r equals to 1. This r here, the first variable here, letter you put here, is to signify this is a variable. This is what I call the general expression. Sorry, erase. General expression. Okay? If I put this as r, this is a general expression, that means this first value will take on this general expression with the first value equals to 1. I repeat one more time. The first value here will be 1 because this is the value of r when r equals to 1. Now the next value will be given by r equals to 2 because it counts numbers like that. The next is a counting number 2. Right? 2. You sub r equals to 2 into this general expression, you will get 2. The next one, of course, is 3. All right, sub r equals 3 into this general expression again, you get 3. Now, what is this 4 for? This 4 is actually the last value of the variable. Okay, the last value of the variable. Okay, so therefore we will stop for this expression, we'll stop at 4. So 1 plus 2 plus 3 plus 4 can be expressed in a summation form like this. Let me quickly add something here. If my general expression is r squared, okay, my general expression now, if it's an r square, then this whole expression will just be 1 square plus 2 square plus 3 square plus 4 square. Maybe I write down for it to be clearer. This is when you substitute r equals to the first value into the general expression. Okay, you substitute r equals this one is the first value. Right, this is the first value. So you substitute r equals to the first value into the general expression, you get 1 square. You sub the next one, r equals the second value, which is 2, you get 2 square, 3 square, and 4 square. Maybe I change the expression a little bit for us to be a bit clearer. What if I now change it like that? I start with 3, I end with 6. And now this time I say this is 2r plus 1 square. Now the principle remains the same. This one will still give you the general expression. This r equals to 3, this r is always the variable. You sub r equals to 3 into here. What do you get? You get 7. So far so good. You sub r equals to 3 into here. Just remember that this is the first value. You get this first value by substituting r equals to 3 into the general expression. You sub r equals to 4 is the next value. It's always by counting numbers. Alright, then you get 9 square. Then you sub r equals to 5 you get 11 squared. And so out of 6, you stop here because this is the last value of the variable, then you get 13 squared. Clear enough? Now what if now instead of the last value is 6, sometimes they will say this is n. So it will stop when r gives you n, which means you will plus on and on until your 2n plus 1, whatever is the value of n. Because at this moment, you don't know what is the value of n. Right? You may want to replay this video a little bit to get this idea, and later on, don't worry, I will illustrate some examples. So just to recap, this is the last value of the variable. This r is the variable that you use. All right, and this is the first value of the variable. Let me illustrate with some examples. What is this then? First, I substitute r equals to 1 into this general expression. Notice, I always say this gives you the general expression. You get 1 square plus 2 square plus 3 square all the way to the last one. You will get r equals to n, you get n square. So far so good. Next, let's look at this example. This time you don't start with 1 square because r equals to 2 is the starting value. You start with r, substitute r equals to 2 into r square. You will get 2 square plus 3 square all the way to, watch this value. This is when this one is the last value of r, which is n plus 1 square. This one, be extra careful. If you look here very, very carefully, j is now the variable. The variable is now j. So be very careful when I substitute here. With my first term, if you get the first term correct, the rest will be correct. Now this is the value when you substitute j equals to 1 into your general expression, which is r. Right? You substitute j equals to 1 into your general expression, which is r. Actually, what do you get? Well, whether j is 1, 2, or 3 wouldn't affect r. So this one is just r. I repeat one more time. Substitute r, j equals to 1 into the general expression r, you will still get r. Plus, next one you sub j equals to 2. You will still get r. How many r's do you get? You will get actually n times of r because the number of terms will just be n, correct? Minus 1 plus 1. So you get r and you actually get n times. That's a short introduction. But let me give you 2 more commonly encountered sums before we go on to try some questions. If you look at this one, you sub r equals to 0, right? You start, that means you get 0 plus 1 plus 2 all the way to last term n. Now, whether you start from 0 or you start from 1, it wouldn't make a difference. This is fine. You write this out, you will know these two are equal. However, it's not always true. If you look at these 2 summations here, if you start r equals to 0 and you start r equals to 1, it makes a difference. Why? Because this is c. You sub r equals to 0 into c, you will still get c. C. How many c's do you get? You get n minus 0 plus 1. So you get n plus 1 c's. Whereas this one, you get n minus 1 plus 1. You will get only n c's. This one is actually just nc. So do not always assume that even if you start from 0, it's the same as starting from 1. Bear that in mind. That's the end of the first part. We will go on to some short quiz.